All right, we're doing the geometric series test, which is basically we are looking at exponential functions. So if you look at our summation equation, we have the sum from n equals 0 to infinity of a times r to the n. That's a times b to the x. Yes, a times b to the x. Okay, so then we have a is our initial value, and r is the constant multiplier. So we get a plus the next term, a times r to the first, plus the next term, which is a times r squared, plus the next term, so on and so forth, until infinity. We call these series, geometric series, the ones that basically have an exponential equation for its a sub n to get its term values, okay? The other important things about geometric series are that if the r value is between 0, the absolute value of the r value, excuse me, is between 0 and 1, so a fraction between 0 and 1, we converge. And if the absolute value of the r value is equal to 1 or greater, then the series diverges. So let's apply our test. Okay, check it. We have the sum from n equals 0 to infinity of 3 over 2 to the n. So I can see that this equation is just 1 times 3 over 2 to the n. So the a would equal 1, my r would equal 3 over 2. And what I need to write is that the r, the absolute value of, no, let's just do this. Okay, the absolute value of r, which is 3 over 2, is greater than 1. So it's greater to or equal to 1. So the series diverges by geometric series test. Cool? Yeah, let's look at the next one. Okay, so this one is not as straightforward because we have to rewrite the equation. So I have n is equal to 0, the sum from n equals 0 to infinity of 3 over 2 to the n. The 3 is just our a. Our 2 over to the n can be rewritten as 1/2 to the n power. So now I can see that my a is equal to 3 and my r is equal to 1/2. So the absolute value of r is equal to the absolute value of 1/2, which is between 0 and 1. Yeah, but the absolute values. So our series converges by geometric series test. Okay, number 3. Okay, this one, again, not as straightforward. Just doesn't look like a geometric series, but then I'm like, oh, maybe if I divide in the 5 to the n into both terms, I can get the sum of 2 over 5 to the n minus 3 to the n over 5 to the n. I'm like, this could work. So I got, now using my properties of series, I'm going to rewrite my series using two summations. So the sum as n from n equals 0 to infinity of 2 times 1/5 to the n power minus the second series. So from n equals 0 to infinity of, this time both the numerator and denominator are being raised to the n power. So we get 3 over 5, and I'll pull the n power outside the parentheses. So really there's just a 1 for our a value. So the left-hand series has an absolute value of r is equal to 1/5. So that the absolute value r is between 0 and 1, so the series converges. Okay, and What we're subtracting out is a series with an absolute value of r that is equal to the absolute value of 3/5, our constant multiplier, okay? So I can see that the absolute value of r is between 0 and 1, so this series also converges. So what I know is that both series converge, so the whole thing, the sum from n equals 0 to infinity of 2 minus 3 to the n over 5 to the n also converges by geometric series test. Okay, so we have to state the condition. Why we know the geometric series test works is because of our R value test here. Okay, all right, let's do two more. So I have the sum from terms n equals 0 to infinity of e over pi to the negative n. So I'm not keen on the negative, so I am going to rewrite it with positive. So remember, when I use a positive exponent, it's going to flip my bases. So the e is going to go to the bottom, the pi is going to the top, and there's an invisible 1 on the outside. And then I write that, so the a is equal to 1, the r is equal to pi over e. So the absolute value of r is equal to pi over e, the absolute value of pi over e, which is greater than 0. This is 3.14 over 2.7, okay? So the series diverges by geometric series test. So we need these two pieces of information, or actually there's three. Okay. To find a geometric series, when it converges, we can actually figure out what value it converges to because we have like a pretty easy formula for that. And so what we know is that if we have a sum that is written as a geometric series, so the sum when n equals 0 to n equals infinity of a times r to the n, we know what value it adds to by just plugging it into the formula a over 1 minus r. So the series here, we can actually figure out the sum. Okay, we know it equals a over 1 minus r. So all we need to do is figure out what our initial term is and what our r value is, and then do some math. Okay, I mean, we're always doing the math. So we got n is equal to 0. The sum from n is equal to 0 to infinity of 3 times 1 over 2 to the nth term. So again, our a sub 0 would be 3, because it's 3 times 1/2 to the 0. So our first term is 3, and our r is equal to 1/2. So substituting that into s is equal to a over 1 minus r, I get 3 over 1 minus 1/2, which is 3 over 1/2 multiplied by the reciprocal. So I get 6. So the sum of the series is 6, which means that the series converges. So if we add up all the terms of the series, all the infinite number of terms in the series, it's going to just equal 6 in the end. Yeah, it's pretty cool. All right, so the next one we rewrote as n is the sum from n is equal to 0 to infinity of 2 times 1 over 5 to the nth power minus the sum from n is equal to 0 to infinity of 3 over 5 to the nth power. So we do have to find, because we wrote this as two summations, let's find the sum of each and then add them together. Okay, so my a, since we're starting with 0, my a is just going to be 2. my r is 1/5. So I get the sum is equal to 2 over 1 minus 1/5 minus the sum of the second, which is my a is 1 over my 1 minus my r of 3/5. So we get 2 over 4/5 minus 1 over 2/5. And when I calculate that out, I get s is equal to 2.5 minus 2.5, which is equal to 0. Yeah, series converges to 0. So it's just basically going to add to 0. Wow. All right, let's do another one. So the sum from n is equal to 1 to infinity of negative 1/3 over n. So I have, here's a little tricky bit, is that our first term has an n of 1. So I am going to figure out what a sub n is, and that's negative 1 over 3 to the first power, which is negative 1 over 3. Okay, and my r is equal to negative 1/3 as well. Okay, so I see that s is equal to negative 1 over 3 times 1 minus negative 1/3. So negative 1/3 over 4/3 multiplied by the reciprocal equals negative 1/4. So the series converges to negative 1/4. So by like actually finding the sum, we can see that like the series is going to add to a value and not just like go to infinity, or we're not going to be able to add it at all. Okay, so this is one of the few like series that we can actually do this, and it's like easy. Okay, so n is equal to 3. So when I figure out my first term, I do need to figure out a sub 3. So that would be negative 3 over 4 to the third. All right, which is negative 3 over 64. And then I am going to rewrite my series as the sum from n equals 3 to infinity of negative 3 times 4 to the n power. So, not 4, 1/4, because that's in the denominator. 1 over 4 to the n power. So r is equal to 1/4. Okay, let's get our sum. The sum is equal to negative 3 over 64 over 1 minus 1/4, which is negative 3 over 64 over 3/4, and then multiply by the reciprocal. So I get a lot of canceling. I get basically negative 4 over 64, which reduces to negative 1/16. So the series converges to negative 1 over 16. Okay, that's the geometric